Thanks everyone for coming. It's such a great audience, more than I expected. I hope I won't disappoint you too much. Just to put everything up in the open, much of what I will talk about today will not be about conflict-driven inequality in the 21st century. I've been here for more than 3 months now. I came in mid-January. Time flies. When I arrived, I thought it would be a super idea, and this would be the perfect time to present early results from new research on inequality throughout the 21st century. Fast forward 3 months, and life have come along, and I'm not yet in a position, unfortunately, to talk at length about that. Simply, we have not come far in terms of producing results. So what I will do, and hopefully this will still be interesting to you guys, I will provide a much broader perspective of my ongoing research portfolio. Some of this may seem to be a bit more like a lecture, bear with me, because I will talk a bit about common risk frameworks that are being used in climate impact research. I will talk a bit about scenarios, because the scenarios are important in my research and will be used in this study. I will end this talk, and I'm not quite sure how much time this will take, we will see. But at some point I will end, but I will end then on referring to at least some very preliminary results that, while not trustworthy on themselves, in and of themselves, I think will be indicative of the kinds of evidence that we plan to produce and to publish, hopefully, at some point in the future. So that was a long caveat, but thanks again for coming. If there is anything that is unclear, feel free to raise your arm, but otherwise I'm sure there should be time when I'm done talking before the colloquium is over to have some more general discussion. And obviously I will be very grateful for whatever comments and suggestions you might have to any of the things I will be talking about. Some years ago, 10, 15 years ago, I did a fair amount of research actually on inequality, especially related to political inequality and how that may vary across or may shape the political power of ethnic groups. But even before then, when I was really starting to look into climate change and climate security for the first time, some people started asking me, so why did you start to look at climate change, and why do you care about the consequences of climate change? Why is that relevant for issues of peace and security? And the story I sometimes told, it's not entirely true, but it's true enough that maybe it is interesting, is about the following. When I finished my PhD, and I moved to a new city in Norway called Drammen. This is an aerial photography of Drammen. I hadn't really started looking into issues of climate and climate security and how the two might be related, or climate and security might be related. But then very shortly after I arrived in Drammen, the local newspaper published 2 aerial photographies on the front page of their newspaper. And the map you see here is one of those 2 photographies published, and the arrow points to my house. That was cool. You know, shortly after moving to a new city, I could actually see my house on the front page of the local newspaper. The newspaper also had a second manipulated photo, this, which showed under extreme sea level rise how this city might look at the end of this century. Now, there's a good and a bad news from this photo. The good news is, at least if I look at my screen, I may be able to still identify my house. The problem is I can only see the rooftop of my house. So climate is something that will affect everyone somehow, and I guess that is the main takeaway here. It is true, this happened. It is not why I started looking into climate and security, but I think it is may be representative of how climate change in various ways might impact everybody's life, even if 6 meters sea level or whatever is projected here may not necessarily materialize within the end of this century. Okay, what am I going to do? Well, basically, I'm going to talk a bit about current ways of thinking about climate change and climate change risks, ways to study that, and some limitations in which climate change risks are being studied at the moment, and how we, meaning me and my colleagues, and there are colleagues in the room also contributing to that, Leon's PhD is partly funded by a project I will be talking about. Nina von Uxkull, who is teaching now, I think, is also part of the project. Victoria, we've been discussing ideas for future research that will be involved in some way. So there are already ties here, I think. And then I will, as again indicated, I will talk more about inequalities explicitly towards the end of the talk. So what is climate change risk? So climate change risk, in the way it is often discussed in the climate change research community, is a function of four things. It's a product of hazard, exposure, vulnerability, and response. And so this figure that you see on the left here is often referred to as the climate risk propeller. This visualizes the risk framework as it is being used by the IPCC, the Intergovernmental Panel on Climate Change, which is the leading scientific body doing research and facilitating research and communicating and assessing research on climate change, its drivers, and its impacts. And politics and political factors, I would argue, are relevant to all four of the propeller blades here. So they may shape climate change risks partly through affecting the hazards. What are hazards? Hazards are extreme weather events. They are sea level rise. They are gradual drying or shifting environmental conditions. And all of those hazards are in complex ways, driven by anthropogenic emissions, by greenhouse gas emissions, for example. All right, and politics may shape and affect greenhouse gas emissions through decisions on energy use, on energy transition, for example. Conflict may reshape country priorities in terms of investing in military versus investing in renewable technology, for example. Or it could also affect the mitigation potentially in other ways, and I think we've seen some dynamics around that after the Russian invasion of Ukraine a few years back. Politics and political factors may also shape human exposure to those hazards, for example, by setting up and enforcing, or not, building codes for where it is advisable and legal to build infrastructure, houses, and not, in order to shield their population from exposure to extreme hazards. Political factors may also shape responses when hazards occur. They may be preemptive responses in terms of early warning, well-functioning political systems that also are geared towards inclusion. They will provide early warning regardless of which part of the population is being threatened by an incoming hazard. In more exclusionary regimes, that may not be the case. And lastly, political factors may shape vulnerabilities to the hazards. And I think that is really the key of what I'm going to talk further about here. So the challenge that I will be relating to is to estimate historical and future role of political factors in shaping climate change risks, in particular through their impacts on climate vulnerability. I will be talking a bit about political development, mostly by using that as an analogy or a complement to socioeconomic development, all right? So by that, I mean broad structural political characteristics, not fluctuating policies per se, but more inherent or rigid political institutions, for example. And my research will in particular, and my presentation today will in particular be relating to institutions and governance as one dimension of structural political development, and then to peace and security, or the breakdown of peace and security as a second and complementary dimension of political development. And those two dimensions, I would argue, and there is literature supporting that argument, are relevant both for the ability and the actual implementation of climate change mitigation, reducing greenhouse gases, and climate change adaptation, adapting to changing environmental conditions and reducing climate risks in that way. So the approach of my broader research agenda that my research is trying to feed into can be broken down into 4 steps. So first, I want to identify through various types of scientific studies in collaboration with a broad range, actually, of colleagues, to identify relevant political development factors that contribute to explaining variation in impacts from climate hazards. So if a flooding occurs, does it matter whether the flooding occurs in a democracy or in an autocracy or in a society struggling with failed governance? Does it matter whether there is a severe armed conflict going on or whether there's been peace for 50 years? Possibly. We want to study that. We want to quantify that. And then, assuming that we will find some signals from political development factors on these climate impacts, we aim to develop scenarios for how political development factors may evolve into the long-term future. And those scenarios may or will consist of two parts. In part, they will consist of narratives, qualitative storylines describing how political development will evolve into the long-term future. And we should have those storylines along different scenarios. And then secondly, we want to make quantitative projections of those key factors that are consistent with the narratives, such that we have, by effect, quantitative scenarios of alternative political development pathways into the long-term future. And then, when all those three steps have been concluded, we want to investigate the implications in the future of being in this political development pathway or that political development pathway for future climate change impacts. That's the broad portfolio of my research. It does not explicitly bring in and consider inequality per se. I would still argue that a lot of the research that goes into this broader research agenda is relevant for inequality, and it is in fact also informed by our knowledge about importance of inequality, political inequality, economic inequality, social inequality, across scales, social scales. All right, yeah, there's the link there if you want to have a look at the project website. All right, what are the scenarios that we're going to talk about here and relate to? What I'm going to present to you now is the dominant scenario framework being used in climate change impact assessments. These are scenarios developed basically on the call from the IPCC to have a structured and formal way of assessing future risks and future impact from climate change, depending on whether societies develop in this direction or that direction, depending on higher or lower levels of future warming. So that scenario framework consists of basically of two elements, societal development scenarios and climate change or global warming scenarios. So the societal development scenarios are frequently referred to as the SSPs, the Shared Socioeconomic Pathways. There are 5 of those pathways, or scenarios if you like. Let's not nitpick about the terminology here. And those 5 scenarios differ by assumptions about the extent to which the world in the future will be able to address climate change mitigation challenges or not, and the extent to which they will be able to overcome adaptation challenges or not. I don't know if this is visible from the back end of this room, but you can see that there are 5 pathways or scenarios here. On the horizontal scale, you have challenges to adaptation from low to high. In a low challenge to adaptation world, typically there will be technological innovation, there will be high levels of income, but also equal distribution of income such that everybody is able to adapt, all right? And everybody is more shielded and protected from climate risk. In higher levels of adaptation challenges, typically lower levels of income, lower levels of technological sophistication relative to the low challenge scenario, and also larger levels of social inequality, meaning that not everybody will benefit from social and technological development. And then on the vertical axis, you can also split these scenarios or these development pathways by either low or up to high challenges to mitigation. What are driving challenges to mitigation? Well, one obvious factor would be population growth. So in future worlds that have larger populations, there will be larger energy consumption, there will be larger food consumption, and that generates emissions. So by population growth alone, you impose a certain challenge to future climate change mitigation. Again, technology is important. In a future world where there's a lot of investment in human development and in renewable and green technology, and we will observe a rapid transition to renewable energy production, you will have lower levels of challenges to mitigate climate change than in a carbon-based future. So the 5 development pathways that we see here have been given names to kind of describe the kinds of worlds that they envision. So SSP1, that would be the rainbow and unicorns kind of future. It is called sustainable development. It basically means that countries in the future and the world collectively in the future will be well positioned to both mitigate climate change, so this would be a scenario that should be consistent with low levels of warming, but that level of additional warming also would produce low levels of risk because adaptation is high, challenges to adaptation is low, all right? The opposite world is called the regional rivalry world, which is characterized by high challenges to both mitigation and to adaptation. This is a highly unequal world, but also a world with generally low levels of technological sophistication, low levels of investments in human capital, continuation of use of carbon-based energy sources, and importantly, very high population growth. Then you have a pathway where high levels of challenges to mitigation is combined with low levels of challenges to adaptation. That world is called fossil fuel development. It's a world in which the economies continue to grow, and it's really a market-oriented world, but there is no political push towards making energy production and consumption more green. It's only a focus on growth over emission reduction. So in this world, there is a rapid economic growth and rapid technological development, which benefits mitigating climate risks. So adaptation challenges are low. At the same time, the fact that the economies are continued to be based on fossil fuels means that mitigation challenges are considered high. The fourth corner is covered by the inequality pathway, or the inequality scenario, which is characterized by low challenges to mitigation. This is because in the inequality pathway, the richer part of the world, the developed countries, they will continue on the current path towards greener technology development. They will succeed in this green transition, but this technology innovation will not be transferred to the developing world. They will continue to struggle. They will continue to rely on carbon-based energy sources. There will be a growing inequality in skills, in income, and because of that, the impacts from climate change that are needed to be adapted are considered high, because those who are the most vulnerable to climate change impacts, the poorest societies, they benefit the least from this economic growth. And then you have an SSP2, which is kind of the midpoint or the middle scenario, which is, has medium challenges to both adaptation and mitigation. So those are the 5 societal scenarios, and I'll get back to why they are relevant and why there are some limitations with them. But they are basically taken for granted in much of, or they are being used in much of the current climate change impact research. We will also be using those scenarios in our work, but we will improve on them. All right, and these societal development pathways can then be combined, as I alluded to earlier, with different climate change scenarios. And there are a range of different levels of future warming. And so here in this second figure, you have each SSP or each societal development as a column, and then each row considers a different level of global warming by the end of this century. And you can see that there are some gray areas. Those are areas that basically are not combinable. So you cannot, in an SSP1 sustainability world, at the same time have very high levels of future warming. That is logically not possible, and there have been integrated assessment models running this, and they have concluded that basically, under the assumptions that go into the SSP1 world, we will not end up by the end of the century in a world with that level of future global warming. Some of the other scenarios are combinable with higher levels of warming, and in fact, SSP3, what we would think of as the most pessimistic societal development pathway, is actually not compatible with lower levels of warming. So again, apologies for the small font here, but the 2 lowest levels of warming, RCP 1.9 and RCP 2.6, are generally considered compatible with the Paris Agreement. So if we go above 2.6, it basically means we will be above 2 degrees of warming by the end of this century. If we want to focus on the most ambitious part of the Paris Agreement, try to limit warming to 1.5 degrees, then we actually are down to the lowest global warming scenario, the RCP 1.9. And you can see that In order to reach that, basically we need to be in the SSP1 world. It's not totally inconceivable to reach that according to integrated assessment models, also in SSP2, but it's not likely. So the blue boxes indicate the most likely combinations. And if you are in SSP3 through 5, we will not be able to reach a Paris-compliant end-of-century level of warming. Yes. The inconvenient truth, and this is where I think it's going to be interesting, or at least that's where I find this to be interesting and relevant to this talk, is that these societal scenarios, these socio-economic scenarios, and you can get that from the title, they actually do not consider political development factors. They do not consider any of the institutions or prevalence of peace and security that we would think would be relevant for climate change vulnerability, exposure, maybe also hazard development. And by design, then, these societal development pathways, they assume that the breakdown of governance and peace will have no bearing on future climate change impacts. We do not think that is in accordance with the best scientific understanding of how things work. A key limitation of these societal development pathways are the fact that they are based on economic models that assume no disruptions in the future. So GDP projections that are produced for each of those SSPs, for each country in the world for each year until the end of the century and beyond in some studies, they produce basically too optimistic growth projections, especially for countries and regions that historically have been struggling with political instability, with conflict, and the societies and the regions that we generally consider to be the most vulnerable to future climate change impacts. And by implication then, SSP-based or these scenario-based impact assessments, they may risk underestimating future risks and future impacts precisely because they also underestimate future vulnerability. And here is one study that we published a few years ago, Jonas and I, and Jonas is also a key member of my research portfolio, where we basically show historical and projected economic growth for the least developed countries of the world. This is a so-called spaghetti plot where each of the lines here represents a country, a least developed country. And the data go back to 1970 and it goes until 2100, and these data are based on GDP projections from the SSP scenario framework. And as you can see, from 1970 until 2013, which I think was the cut point for the historical data in this particular version of the GDP data, you see there's a lot of fluctuations in economic growth. And among the least developed states, there is not a strong growth during this period, right? Actually, the average growth rate for those countries over these 45 years or so is 0.1% annual increase in GDP per capita. All right. What happens when we go forward? Well, suddenly all of those countries experience massive economic growth, right? In GDP per capita, in income per citizen. This is in SSP3, which is supposed to be the most pessimistic or the least optimistic development pathway. In other SSPs, they grow even faster, all right? Why do they go so steeply? Well, because the economic model, the solo model that is commonly used by economists, has this assumption about growth convergence because it is always more expensive to invest in developing new technology. So being at the research frontier is more expensive than catching up by buying or receiving that technology further down the line. That model works unless there are disruptions to growth. What are sources of disruptions to growth? There can be many. There can be economic sources of growth disruptions, but there can also be political ones. And that's where we want to investigate a little bit. Because we do not think that this SSP3 world for the least developed countries is kind of the most pessimistic future for those countries that we can think of. And the point about these SSP scenarios is that they are supposed to span, you know, the total plausible range of future. So just to be clear, none of these 5 SSPs are intended to be predictive in a sense that we believe in one of them more than the other. But the thing is that in total, they are supposed to capture more than the breadth of what is a likely future development. And by implication then, since this is from SSP3, if we're going to trust this to be realistic representation of the least optimistic future, it basically means that we would think that the least developed countries will, in the real world, grow at least as fast as this. We don't think that is a reasonable assumption for the worst case future scenario. All right, and in fact, the developers of the GDP data themselves, they acknowledge this in a footnote or during the text, and they say something like the projections of GDP disregard a wide range of country-specific drivers of economic growth that are outside the narrow economic framework of the solo growth model that is commonly used, such as external shocks, governance barriers, blah, blah, blah. All right, so there is some work to be done by political scientists here, I think. So, does it matter? I mean, okay, so the GDP projections are overly optimistic, and it looks good if you want to have a positive outlook of the world. But does it really matter? And we would argue that yes, it does, because this unduly optimistic modeling of the future world, especially in SSP 3 and 4, which are supposed to be pessimistic, have implications for what we think would be reasonable future impact from climate change. Why? Because economic growth, or GDP per capita, is widely seen as a good proxy for vulnerability. And if projected GDP per capita is higher than what is likely to materialize, it means that we assume or we project that vulnerability will be lower than what it in fact will be, and therefore that projected risks also will be lower. And we think we would want to have reasonable risk and impact estimates, and not just overly optimistic ones. Here are 3 examples, and sorry for shaming the authors named here, but these are 3 studies taken from the literature that use the SSP framework to model implications for other outcomes that we care about. We can think of them as risks or development outcomes. On the left here, we have projections of future hunger for each of the SSPs. The 2 lines here, for some reason, they chose green for SSP3, which nobody should choose green for SSP3. Anyway, they did. And so this is the worst case future projection of hunger. And even in the worst case future, by 2030 or 2040, we will have almost halved the number. And this is not even the ratio of hungry people in the world. This is the number of hungry people in the world. And in SSP3, there is a very steep population growth. Even so, we see a dramatic drop in hunger. We do not think this is the worst possible imaginable future world in terms of food security. Rule of law, again using SSP data as input, they suggest that in the least optimistic SSP3, here it's red, so that's fine. Even that one suggests that, you know, average rule of the world, rule of law in the world will be better in the future than it is today. That's not totally implausible, but is that the worst case scenario we want to play with if we are going to look into climate change impacts? I don't think so. This last one is modeling good governance. Again, you see that even in the SSP3, the worst case future world, the quality of governance in the world will continue to grow, all right? And of course, it will grow very steeply in SSP1 and SSP5 because those 2 scenarios have even stronger economic growth, lower population growth, and higher investments in education than SSP3, for example. All right, I think you get my point now. Let's see, where are we at? Yeah, so what we need are political development pathways, or, you know, specifically designed political scenarios that can complement the socioeconomic scenarios and kind of moderate and add some more nuance to these very optimistic economic projections. So that's what we're going to work, and that's what we are working on in the project that I'm leading. So what we're going to do is, first of all, we are going to follow the logic of the SSPs by defining each of those development pathways, political development pathways, by how they should look at the end of the time, end of this century, typically 2100. They should also be consistent with assumptions of the SSP, such that in an SSP1 political future, it should be a world that generates low challenges to mitigation and low challenges to adaptation. So obviously we need those political development pathways to be informed by our best knowledge about how political factors shape both mitigation and adaptation, right? And then, as I've already mentioned, I think, we will then produce both qualitative storylines or narratives that describe these 5 alternative political futures, And then we will produce some quantitative projections that correspond to these qualitative narratives. I'm not going to go through the thing on the right. You can't read it anyway. It's from a draft paper. All right, so just to recap the approach. So the first point is to identify political development factors that have some meaningful impact on the variation in, well, that shapes the variation in climate change impacts on societies. And so here, work is currently underway to estimate how political factors may shape climate-related impacts. I'll give you a brief example of that in a minute. The second stage will then be to develop these narrative storylines. I've already mentioned that this will be informed by the available literature. We are also going to conduct an expert elicitation to draw on experts' more informal knowledge about how political factors may either impede or facilitate society's ability to mitigate and adapt to climate change. When that's been done, we're going to create these quantitative projections. Since they depend on the result from step 2, we haven't started on that work yet. And then step 4 basically also depends on step 3. At the same time, we don't have the patience to wait until the quantitative scenarios are done. So we are already doing some shortcuts in order to explore how political development factors may moderate future risk. And in fact, this inequality paper that I hope to present, and I'll give you a glimpse of it in a few minutes, is part of this stage 4, looking into how alternative political futures may shape alternative levels of economic development, inequality. All right. Last year, in February, what happened, Victoria? Your defense, yes. Yes, and I was privileged and fortunate to be here. And in association with that defense, you facilitated a cluster seminar, and I presented this slide, among others. And some of you in the audience were here at that presentation. And that is a paper. It is in nth round of review at the journal. We'll look into what is effectively under step 1 of my approach slide. We try to explore how political context moderates human impacts of flooding, all right? And I'm not going to go into much detail about this plot, but I want to say a few things. We basically focus on fatalities from flooding at global scale, using data available since the year 2000. So we have many countries over many years, and we have information about specific flood events. We have information about fatalities from those floods. We have information about how many people were actually exposed to flooding. We have other information that is measured uniquely for each flood event, including the number of people killed in conflict within the flooded area using high-resolution satellite data, etc. So we have a lot of information for each flood event. And then we run our regression models where we estimate the influence of different political factors for only a subset of the data for the year 2000 until 2014. And then we predict out of sample for the years from 2015 until 2018. We try to predict future fatalities from flooding using observed data for the predictors. All right, and so the red distribution that you maybe see here basically shows the distribution of our predictions at global scale for the period since 2015 in terms of flood deaths per event. And we can see that, you know, we basically do not predict almost any. I think we may have truncated some extreme predictions, but basically we do not predict almost any flooding that actually occurred since 2015 to have more than about 150 fatalities. I'm sure that in some cases this might be considerable under estimation or under prediction, but that's the best we could do. And we see that, you know, the median prediction actually is somewhere around 40 fatalities. So the median predicted fatality number across all the floodings that we know occurred between 2015 and 2018, our model predicts based on observed data on the political context of those countries, the economic context, etc. We predict around 40 flood deaths, the median estimate. And then we do this counterfactual thought experiment where we say, okay, let's assume that everything actually is the way it happened, except we replace the observed political institutions with a dream scenario. And we replace whatever violent number in terms of battle-related deaths in these countries with 0, meaning we assume that what if there had been peace instead in these countries that were under conflict and then experienced flooding. And so in terms of thinking about a dream scenario, we decided to select a specific country, and so we picked New Zealand. And so we say that let's hold everything else constant, but we replace the political development characteristics, the democracy score, or the score for accountability, inclusion, blah, blah, blah. We replace the actual scores for each country with the score for New Zealand in 2015. And we do the same with the conflict variables. New Zealand didn't have any conflict in 2015, so that means basically replacing whatever number of battle-related deaths the country actually had with 0. We do know on the other changes, and we rerun the predictions, and then we get the blue distribution. And here we see that the median predicted fatality number is something like 20, so about half. So it would seem then, based on this prediction analysis, that the median predicted flood deaths could be reduced by half if all countries had been enjoying the same political characteristics as New Zealand had, instead of having whatever institutional characteristics that they did have during this period 2015 to 2018. And in fact, yeah, when we do this for all models, we conclude that at least the median estimate, the mean estimate is a reduction by 55% in flood fatalities. And we refer to this as the potential gain of achieving SDG 16, because we think of New Zealand as a country that has received or has achieved peace and justice and strong institutions, which basically are the 3 elements of SDG 16. So if SDG 16 had been achieved by 2015, the first year of our prediction and the first year of the SDG framework, flood deaths in the next few years could have been, according to our prediction, reduced by about half. That's a massive number and indicative of the potential role, I think, of political factors in shaping climate hazard impacts. All right, so that was just an example of work under point 1. And then, as I mentioned, I think this inequality study that I'll get to now would correspond more to number 4, because we're going to look into the future. And this is work that I've said now multiple times that really is in a very early stage of development, which is why I will only spend a few minutes on it here. First of all, I want to give a big shout out to my collaborators, Kristina Petrova, who is based at PIC and also Uppsala University, and Hannah Frank, who is submitting her PhD thesis in these days, I think, who is based at Trinity College, Dublin. And they are basically doing the heavy lifting of this paper, so they are really to credit for this exciting work. So the motivation for this study is basically that since GDP projections within the SSP framework, we believe, are too optimistic, especially for the low-income countries, it by implication means that projected future income inequality also would be lower than what we think are realistic, especially, again, referring to this worst case or more pessimistic scenarios like SSP 3 and 4. So what we're going to do in this paper is to adjust these GDP projections by actually accounting for future conflict risk, because we know that conflict is bad for the economy, and it is possible to quantify the average treatment effect of an average conflict on GDP growth. And so basically that's what we're going to do. So we develop this simulation system that simultaneously estimates 1 year at a time for each country, many times over, what's this year's GDP growth and what's this year's conflict, and then they inform each other, the estimates inform each other, and we average over many simulations. And then we calculate, based on these conflict-adjusted GDP projections, we calculate the Gini score, or the income inequality scores. We also compare the 80th, the top 20 to the bottom 20 percentile income distribution also, but I'm not going to show that here because everything is preliminary. And then we are going to compare the Gini scores based on these conflict-adjusted GDP projections with Gini scores developed using the existing GDP projections from the SSPs. There's also been studies published reporting exactly those Gini scores, assuming that economies will continue to grow without disruptions in every country, in every scenario. And then, and this is a big question mark, we might want to do the same for within-country inequality. I think it is increasingly likely that we will not do that in the same paper, but we will rather consider doing a separate paper on within-country inequality. And then, and this is probably more likely to be included here, is to not only focus on conflict-adjusted GDP growth estimate, but also the compound effect of conflict and climate hazards, because that could add an additional cost to the development of especially low-income economies. But we'll see about that. Maybe that also will be one step too far. All right, and in doing this work, we will be basing ourselves on a previous study led by Kristina Petrova, in which they try to estimate loss of GDP in the future from continued conflict risk. And this plot on the right is taken from that study, and it basically identifies a few countries, but each of the dots represents a country by the end of the century, and how much loss, cumulative loss in GDP per capita, going down to 70% because of future conflict risk relative to the SSP projection, which assumes no conflict in any scenario. Nigeria is the unfortunate country that seems to suffer the most from future conflict risk, with its projected mean loss of GDP per capita relative to the SSP projection by 70%. So the income by the end of the century will only be about a third of what the OECD SSP projections suggest. Some countries, and Iceland is on top, actually in this model seems to gain a little bit if we account for conflict, but those estimates are probably not very significant, so I don't think we should put too much emphasis on that. Here are maps that basically shows for each country and for each SSP, from SSP 1, 2, 3, 4, 5, how much they lose by when we account for future conflict risk relative to this SSP projections, these SSP projections that do not include conflict. I just wanted to highlight, and this is something we obviously will fix, that the color scale here is counterintuitive, since red actually means that countries may benefit, and blue suggests considerable loss of income in the future after accounting for conflict risk. But in any case, everything is preliminary. There are some red or orange countries here that seemingly either benefit or at least do not lose as much after we account for conflict risk. Those countries tend to be very low population countries: Mongolia, Namibia, Botswana, down here, Scandinavia, Iceland, obviously. These are all low population countries, and since we know that population growth is a strong driver of future conflict risk, the countries with low population will be penalized much less in this conflict-adjusted GDP estimation. Then looking one step further, we can then project Gini scores for each SSP. And on the left, we have Gini's produced directly from the SSP projections. Then we use GDP projections after adjusting for conflict risk. And here, and this should actually be, again, flipped, but this is super preliminary. But these are then the difference between the two in percentages, wherein, for some reason, we get SSP2 as indicating the biggest gap between Gini scores based on the existing SSP projections and our conflict-adjusted projections, where Gini actually is 30% lower when we do not account for or adjust for conflict, meaning that inequality will be higher, obviously, if we account for conflict. And you can basically see that by eyeballing these two plots. So this is with conflict adjusted, and even in SSP 1 and 5, the most optimistic scenarios, Gini scores by the end of the century at point, I don't know, 22 is, yeah, no, it makes sense. Yeah, at point 22, when we adjust for conflict, is still pretty low, but if we do not account for future conflict risk, projections for those two pathways are more like 17 or 18. All right, that's basically where we are at the moment. In fact, we are now reassembling all of the data. These simulations were based on replication data from this study. We want to reassemble and do some adjustments to the research design, and then rerun everything with more updated data. So stay tuned. So just to preliminary conclude, let's see what it says. Political context, and especially quality of institutions and prevalence of peace, which are the two dimensions that I've been focusing on here, seem to matter for socioeconomic development in terms of conflict-adjusted GDP, for example, that I just showed. Vulnerability to various types of hazards. I showed you flood fatalities and how that will differ depending on your political institutions, and thereby climate risk. Long-term projections of between country income inequality that ignore political context are prone to misrepresent, at least, and likely underestimate future inequality. And that's, I think, what this is supposed to show, except it shouldn't be minus, it should be plus. Yeah. Tentative estimates suggest that global Gini may increase by more than 30% at the end of the 21st century when we account for armed conflict, relative to the same future without conflict, right? Doesn't mean necessarily 30% more than today, but relative to the counterfactual if there is peace on Earth. And as I already mentioned, this analysis will be rerun, drawing on new data and slightly adjusted models. And I think that concludes my talk. Yeah.